Hello dear viewers. This time from this substance, potassium oxalate, we will make this gas, carbon monoxide, that burns with a pretty blue flame. Stay tuned and have fun watching. Anyone who knows this channel already knows this warning. If you are here for the first time, please skip back and read carefully. Carbon monoxide is a colorless and odorless gas. It arises from the incomplete combustion of carbon-containing substances with insufficient oxygen supply. It is produced industrially by injecting carbon dioxide or water vapor into white-hot coke. Carbon monoxide is an important raw material in the steel and chemical industry. As a component of town gas, it was also used as heating and lighting gas until the middle of the 20th century. And who knows, maybe it will experience a renaissance in these times. However, it has one major disadvantage. Carbon monoxide is a dangerous respiratory poison because it's easily absorbed through the lungs. Since the gas is colorless, odorless and non-irritating, it's hardly noticeable. It's considered to be the cause of more than half of all fatal poisonings worldwide. In this respect, it can be described as the numerically deadliest poison in the world. High time for production in a laboratory. We make it by pyrolyzing potassium oxalate, which we synthesized in the last video. This occurs as a natural component in clover, so we produce a heating and poison gas from a meadowherb mineral. We use a diamine silver complex solution to detect the gas. Since it tends to form explosive decomposition products, it must be prepared fresh and used immediately. To prepare the reagent, a spatula tip of silver nitrate is first dissolved in a few milliliters of distilled water. Then 1 to 2 milliliters of diluted caustic soda are added, whereby silver oxide is precipitated. If about the same amount of diluted ammonia solution is now added, the precipitate dissolves into diamine silver when shaken. Because of the toxicity of carbon monoxide, we move the pyrolysis outside. About 5 spatulas full of potassium oxalate are placed in a test tube, which is then clamped horizontally in a tripod clamp. The oxalate is strongly heated in it, and the resulting gases are introduced into the reagent solution via an angle pipe. The previously clear solution turns black from finely divided metallic silver, which is a result of the reduction of silver ions with carbon monoxide. This was previously formed from the oxalate with the formation of potassium carbonate. After cooling, let's take a look at the pyrolysis residue. Condensed water can be seen in the upper part of the test tube, which has escaped as crystal water. The crystals have lost their luster and have clumped together into an off-white mass. In the lower parts of the test tube, which were directly exposed to the burner flame, carbon residues can also be seen, which often occur in the incomplete pyrolysis of organic substances. For the second part of the proof that the decomposition actually took place as shown, we add some diluted hydrochloric acid to the white mass. This foams up a lot and releases carbon dioxide, evidence of carbonates. Finally, we heat a second portion of potassium oxalate again to provide this proof of carbon monoxide with combustibility and flame color. We do this again outside, this time in the evening darkness as the flame is almost invisible in daylight. We apologize for the poor visibility, but what is important can definitely be seen clearly. The gas, which we discharge to the side, because it has a very similar density to air, may only be ignited at the glass nozzle, which we have prepared with some steel wool to avoid flashback after the result of the pop gas test has been negative. No, that has to be repeated. Much better and very nice. And here, finally at the nozzle, the typical bluish flame of our toxic fuel gas from clover salt, carbon monoxide. Thanks for watching. We hope you enjoyed it. Comments and ratings are welcome. Stay tuned for more videos from this channel. You can find our highlights at the top right. See you soon!